Today I'm going to show you how to get a derivative on your calculator. So we're going to be using a calculator, and this has to be a graphing calculator. It can either be a TI-83, TI-84. If you have a TI-89, it does a lot better things than these, but we're going to use a graphing calculator to find derivatives. For example, let's say we have f of x being equal to 3x minus 2 over 2x minus 3. And we want to find the derivative of that at point 2,4. So let's say we want to find the equation of the tangent at a couple of points. Let's say we're going to look at point 2,4, and then we'll look at point -1,1. Well, we could do it the long way, which means you can use the quotient rule, derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared, and then plug in x equals 2. But if you want to use your graphing calculator, if you're allowed to use your graphing calculator, which sometimes you are, I want to show you how to do that. So first of all, take your graphing calculator and put that function into y1, 3x minus 2 over 2x minus 3. You can use a fraction button if you want, or you can just surround the numerator with parentheses and put divided by, surround the denominator with parentheses. So if we take a look at the graph of that, we can probably remember back to the fall that this is a hyperbola, has a vertical asymptote here and a horizontal asymptote as well. But let's say we want to find the equation at this point 2,4 on the graph. Well, what we can do is have the calculator calculate this derivative by doing second trace down to option 6, dy dx. Now what we're going to do is plug in the x value. Right here it's sitting at x equals 0, but I want to plug in the x value of the point that I want to find the derivative for, so I'm just going to plug in 2. So when you plug in x equals 2, it will give you the value of the derivative, and usually because of the software involved, these numbers are really not important. The derivative is actually equal to -5, which means the slope of the tangent here is -5. So now all we have to do in order to write the equation of that tangent line is use a point slope formula, which says y minus y1, y minus 4 is equal to m, which was the derivative. The calculator told us it was -5 times x minus x1. And now what we can do is put that into y2 and just add 4 to both sides. So it'll be y equals -5x minus 2 plus 4. And when you put that in, this is just a checking to make sure that that the tangent line just sweeps through that graph at one point only. So here it is at point 2, 4. And if you wanted to zoom in, you could really see that that's tangent. Let's do another example. Let's find an equation of the tangent at point -1, 1 of the same function. So we're going to go through the same steps again. Second calculate, option 6, the derivative, and now we have to put in the new x value of -1. Right here it's telling us our derivative is -0.2, which is just the same as -1/5. So if we wanted to write the equation of the tangent line there, we would do y minus y1, which is y minus 1, equals m, which is -0.2, or you could use -1/5, times x minus x1 minus a -1. And then if we wanted to put that into y equals, just add 1 to both sides to solve it for y. And so we'll put that into y2 to make sure we're right. -0.2 times x plus 1 plus 1, I think it was, yeah. So if you graph that, there's the original function, and here comes the tangent that sweeps across this graph at point negative 1, 1. So I just wanted to show you that little trick on the graphing calculator. If you're asked to find the derivative, a numerical derivative, not a formula, but a numerical derivative of a function, you can just put it in y1, and after you get it in y1, you can just do second calculate option 6 and put in any x value. The x value's got to be on that graph. So say we wanted x equals 6. And the derivative of that point at x equals 6 is this very, very low slope tangent. So now what I want you to do to practice is I want you to take your textbook, your calc textbook, and go to page 121. We haven't really worked a whole lot lately with trig derivatives, so I'd like you to do 27 through 41 odd. All of these are trig functions, so you might have to get out your the derivatives of all the trig functions, those notes that you took a while ago. And sometimes you're going to have to use the product rule on 27. Sometimes you're going to have to use the quotient rule, like on number 29. Or sometimes if you get a square root, make sure you call this t to the 1/2 power. So go through 27 through 41, odd, and you can always check your answers at the back of the book after you get all done. And then I'd like you to do, towards the bottom of the page, I would like you to do numbers 47 through 55 odd. It just goes one question over to the next page, but 47 through 55 odd. And this little symbol here means use your graphing calculator. So you can put these in y1, these functions, and use that little trick I showed you. Put the x value in when you're asking the calculator to calculate the derivative of that. And if you'd like to go ahead and write the equation of the tangent line at this particular point, just use the point slope formula on this, but find the derivative at this x value, at this x value, and then do the same thing for 51, 53, and 55 down towards the bottom. And then a couple other things I'd like you to do. They're asking you to find a second derivative of a couple of functions. So over on the next page, numbers 73, 75, and 77, I would like you to find 3 second derivatives for those questions. And that'll give you enough to do tonight. See you tomorrow.